So part of the periodic trends chapter, chapter 3 of the IB syllabus, is on the acid-base character of the period 3 oxides. Now, I usually leave that out until we get to the acid-base topic because it seems a little out of place until you know a bit more about what acids and bases are. So here it is. As we learned about a lot of different periodic trends, properties that change gradually as you go across the table or as you go up and down the table, there is actually a periodic trend for acid-base character. And so for you to discuss that trend, you only need to look at period 3. So that's row 3 of the periodic table, and you're looking at the oxides. So that means all of the compounds of the elements in that row that are formed with oxygen. So I've listed all the different compounds of period 3 elements with oxygen. So these are the period 3 oxides. And we go sodium oxide, magnesium oxide, aluminum oxide, and then we get to silicon dioxide. And there's a couple different forms of phosphorus oxides and sulfur oxides and chlorine oxides. But the general concept is that oxygen is a nonmetal. And so when oxygen is with a metal, like sodium, magnesium, or aluminum, you're going to have an ionic compound. As you get to silicon dioxide, you have that trick compound that looks like it should maybe be able to be drawn like carbon dioxide, but is in fact a giant covalent network solid. And then beyond that, you've got nonmetals with nonmetals, and so you have covalent molecules. So you're going from extremely ionic character on the left and getting increasingly more and more shared electrons, more covalent character as you travel to the right of the periodic table. So as a result, that leads to some differences in how they'll react with water and how they'll behave as acids and bases. And so if you remember that the first group are referred to as the alkali metals, alkali, alkaline, these are terms that mean basic. So it's a pretty easy way to remember that the left-hand side of the table is the basic side of the table. And if it's a trend, we're going to get increasingly acidic going to the right. So the first two compounds, Na2O and MgO, are both considered to be bases. Aluminum oxide is actually a compound we refer to as amphoteric, meaning it can act as both an acid and a base. And once you get to SiO2, you have a slightly acidic compound, and then these compounds over here are all considered to be strongly acidic. So the metal oxides are basic, whereas the non-metal oxides are acidic. So just like any property, whatever the metals have for the property, the nonmetals will be opposite. And let alkali metals remind you that the metals form basic oxides. So the reactions of some of these oxides with water, if we skip ahead and I show you the syllabus says oxides change from basic through amphoteric to acidic across a period. That's the understanding to take away. And you should be able to construct equations to explain the pH changes for reactions of sodium oxide, magnesium oxide, phosphorus oxide, and the oxides of nitrogen and sulfur with water. So if we jump back, sodium oxide and water and magnesium oxide and water, these are two you need to know, and they're fairly simple. All they do is they react with water to form bases. They form hydroxide solutions. So it's really easy to balance. Actually, no real coefficients are required except that 2, and you form the balanced out hydroxide. You need 2 hydroxide with magnesium to balance its charge. Aluminum oxide is rather tricky. It doesn't look like you really need to be able to show these equations anymore for the SL syllabus. You used to have to. But the thing to remember is that aluminum oxide is amphoteric. It's not amphiprotic. It doesn't have any protons, so it can't donate protons. But it can still act as an acid, and it can still act as a base based on other definitions of what it means to be an acid or a base. So aluminum oxide can react with HCl and neutralize it, and aluminum oxide can react with NaOH and neutralize it. These reactions are fairly complex, and so the details of them you don't need to know. But it's important to recognize that aluminum oxide is not something that you can dissolve in water and to turn it into a solution. As a solid, it can actually neutralize both acids and bases. Aluminum oxide is an extremely hard compound that's actually often found on sandpaper, the hard stuff on sandpaper. So it definitely does not dissolve in water, but it is amphoteric. It can neutralize both acids and bases. On the acidic side, here's P4O10 combines with water to make H3PO4. Now this is the unbalanced version of the equation, so we can balance this in class. But that's all it does. When you react nonmetal oxides with water, they combine to form acids, recognizable acids. So the phosphorus ones combine to form phosphoric acid. The sulfur ones combine to form sulfuric acid of slightly different types. And the chlorine oxides combine to form chloric acids of different types. Not hydrochloric acid, but these different forms of chloric acid. So one more to go, the SiO2, kind of like the aluminum oxide. SiO2 we know is a network solid. It's not going to dissolve in water. It's a really strong crystal of quartz, but actually that crystal of quartz is capable of neutralizing bases. So it does have a slight acidic nature to it. Okay. And so that's the overview of the trend. Reminder that the trend goes from basic alkali metals at the left over to more and more acidic on the right. You should note of special importance that aluminum oxide is amphoteric and it can neutralize acids and bases. And you should know some of the reactions of these compounds, certain compounds with water, the ones that I outlined on the syllabus.